So for this problem, we have 12 equal charges Q that are situated at the corners of a regular 12-sided polygon, just like a clock, and we want to find the net force on the test charge Q, big Q at the center. So if we have, let's draw it out. If we have a y-axis, our x-axis, we have a test charge Q at every axis, and then 2 in the middle between each one. Q, 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 Q. So that's all of our charges, and then we have a test charge in the middle of big Q. And all of these are at 1. To make math simpler. So we know that we need to find the position of our vector, the position vector of the charge Q at any point of all of our equal charges of Q. So to find that, we have R is equal to R times cosine negative pi over 2 plus 2 pi k over 12 sine negative pi over 2 plus 2 pi k over 12. Where k is in between 0 and 11. So now we just need to use the principle of superposition, and add the electric forces vertically. So we have, to find our force, we use this equation. 1 over 4 pi epsilon naught qk big Q k k, which then equals 1 over 4 pi epsilon naught little q times big Q r squared 0 minus k for r, which then equals little q times big Q 4 pi epsilon naught r cubed times k equals 0, 11 times negative k. I'm sorry, in these k's, just to make it clear, are not multiplied. It's r sub k. R sub k. We can change that and plug in our position vector. So we get negative Q over 4 pi epsilon naught r cubed just plug in our superposition vector that we got earlier. Our cosine negative pi over 2 plus 2 pi k over 12 sine negative pi over 2 plus 2 pi k over 12. And then we get negative Q times big Q over 4 pi epsilon naught r squared. Okay, 0, 11. Cosine k minus 3 pi over 6. I'm sorry. Put my vector sign in the wrong place. K minus 3 pi over 6. We just need to, like I said, add them all vertically so we get Q times big negative little q times big Q all over 4 pi epsilon naught r squared. And then our vector will be cosine negative 3 pi over 6 plus cosine negative 2 pi over 6. And that will go all the way to 8. Then our other part of our vector would be the same thing with sine negative 3 pi over 6. And that will also go all the way until 8. So from that, since we know they both go to 8, we know both of them go to 0. So then we ultimately get negative low q big Q 4 pi epsilon naught r squared multiplied times the vector 0, 0, which ultimately gives us 0. For part B, if the charge at 6 o'clock is removed and then the downward force from the 12 o'clock charge remains uncanceled, we know that part B, we know that F negative Q big Q over 4 pi epsilon naught r squared y hat. So we use that equation. 1 over 4 pi epsilon naught. K, which equals negative Q big Q over 4 pi epsilon naught r squared 11 K K minus 3 pi over 6 sine K minus 3 pi over 6. That then equals negative Q 4 pi on r squared for vector K equals 1, 11 cosine K minus 3 pi over 6, 11 K equals 1 sine K minus 3 pi over 6. Then we get negative q over 4 pi epsilon naught r squared. There's a vector 0, 1, which ultimately, since this is 0, we just get negative q 4 pi epsilon r squared and y hat. Now we suppose if we had 13 charges instead of 12, so we can add an extra charge q here. So that would give us a new superposition vector or position vector, which would be r. Okay, so r sub k, r cosine negative pi over 2 plus 2 pi k over 13, and then sine negative pi over 2 plus 2 pi k over 13, where k is somewhere between 0 and 12. So when you solve for the force, use the same equation as before. It's just now, instead of 12, we have 13. So it'd be 1 over 4 pi epsilon naught, small q, k, big Q. That would then equal 1 over 4 pi epsilon naught r squared, 0 minus position vector over r, which is simplified to q, small q times big Q, negative, well, wait to the next step, q 4 pi epsilon naught r cubed 12k 0 negative r. Okay, which then gives us negative q k 4 pi epsilon naught r cubed r. Okay, it's negative q 4 pi epsilon naught r cubed cosine, vector, the same vector that we found here, cosine, which is our position vector for r sub k. That'll be cosine negative pi over 2 plus 2 pi k over 13 times sine pi over 2 plus 2 pi k over 13. And that can be further simplified to negative q 4 pi epsilon naught r squared 12 k equals 0. You have cosine 4k minus 13 pi over 26. And we have sine 4k minus 13 pi over 26. And we just continue to simplify. Q over 4 pi epsilon naught r squared 12 equals cosine 4k minus 13 times pi over 26. And then the second part of our vector. Okay, 0 sine 4k minus 13 pi over 26. Since both of these, like the example above, go to 0, equals negative q times big Q 4 pi epsilon naught r squared times the 0, 0 vector, which ultimately gives us 0. And for our last part D, if the charge at 6 o'clock is removed and the remaining 12 charges conspire to produce the same force as before, then we get the equation F is equal to negative Q over 4 pi epsilon naught r y hat. So then F will equal 1 over 4 pi epsilon naught big Q squared times cursive R hat, equal to negative Q over 4 pi epsilon naught r cubed same position vector as before. We get negative QQ over 4 pi epsilon naught r squared times our position vector. Sine 4k minus 13 pi over 26. So then also gives us negative Q big Q over 4 pi epsilon naught r squared times our 0, 1 vector. So ultimately, since that goes to 0, we just have something in the y hat. It'll be negative Q big Q 4 pi epsilon naught r squared y hat. Thank you for watching this question.